Hi kids, it's Mrs. Geiger here, and today we are going to be looking at Table G. So take out your reference tables and turn to Table G. And we're going to be focusing on a substance called sodium nitrate. So find the line for sodium nitrate. Here it is. All right, so you want to focus on the line for sodium nitrate. It's confusing as far as graphs go because there is so many different lines, but you're only going to be asked about one substance at a time, so you want to be able to focus on that substance. So right now it is sodium nitrate. What you'll see is that I have sodium nitrate here, and I'm going to be making an aqueous solution. I'm going to use this beaker, okay, and I'm going to put my aqueous solution into this beaker. Now we need to take a look at Table G and see how much water I should put in the beaker. So make a prediction. How much water am I going to put in this beaker? All right, so you're going to take a look at the y-axis, and you'll notice that on the y-axis here, it is calibrated for 100 grams of water. So I need to put 100 grams of water into this beaker. All right, so I have a balance here. I'm going to turn on my balance. I'm going to zero it. And then I am going to place my beaker onto the balance. Let me move my balance closer so that you can see the reading on it. And you'll notice it says 98.49. That's just the mass of the beaker. I don't want that, so I'm going to go ahead and zero my balance out. And then I have measured out in this graduated cylinder about 100 milliliters of water, because I know that the density of water is that there's 1 gram in each milliliter. So I measured out 100 milliliters, and let's see what mass that comes out to. I'm a little short. So I'm going to go ahead and just add in 1 more gram of water. I want it to be exactly 100.0. All right, so this entire graph is based off of 100 grams of water. So if I have 100 grams of water, that's going to be the solvent for all. Don't go anywhere, stay here. All right, so exactly 100 grams of water. So you'll notice on the graph that it's not only dependent on the amount of solvent, but you will also see that the graph on the x-axis has to do with temperature. So I need to find out what the temperature of this water is. I'm going to give it a little swirl just to make sure. All right. And so my water temperature, let's see if, I'm not sure if you're going to be able to see this in the video, But I got very cold water, so my water has a temperature of 18 degrees Celsius. All right, so this water has a temperature of 18 degrees Celsius. So find how many grams of NaNO3 I should add into this beaker to make a saturated solution. So here's the idea. When I take a look at this graph, I'm going to find, sorry, I moved the whole guy. I'm going to find where my 18 degrees Celsius matches up with my line for NaNO3. Oh, that zoomed in. That was exciting. So here's the line. There's 20. So here's about 18. So I'm going to estimate that I need about 87 grams of this salt in order to make this solution. So I'll be right back. And we're back. So I have added 86.20 grams of sodium nitrate into this weighing dish. I'm going to go ahead and move the beaker here, and then I just tilt my view so that you can see what happens when I add this massive amount of salt to the water. So if I just add some of it, okay, if I just add some of it, and then I use a stirring rod, we don't want to stir with a thermometer, that's poor lab technique. So I take my stirring rod. When I take my stirring rod, I can agitate the solution or stir it up. And when I do that and I agitate this solution, I can get more of the solute to dissolve faster. I do this every single morning to get the sugar to dissolve into my coffee, and you probably have done this as well. I'm going to pause and come back when this has all dissolved because I'm just stirring. So we're back, and you can see that this is now a homogeneous mixture. You can tell that all of the salt crystals that I put in there have dissolved. But this is not at its limit. Remember, I only put about half of the salt in. I have all of this other salt, I have all this other salt that I masked out that still needs to go in here. So there's a term for this. If this has not yet reached its limit, I've only added about 40 grams, so I am in this section of the graph here. Oopsie, I zoomed in again. I didn't mean to do that. But I'm in this section of the graph here. Hold on, let me fix this. We're back. So we haven't yet reached the limit. The limit would be 86, or now we're probably, 86 or 87 grams of that solute, which I masked out. That is the maximum amount that at this temperature the solution can hold. So the solution is kind of like juggling these particles. Right now, I haven't yet added as many salt crystals as I could. So this solution is not saturated. It is said to be unsaturated. Unsaturated means that I have an amount that's less than the limit. It's not totally full. All right, so the term saturated basically means full. So if I wanted to make this a saturated solution, I'm going to have to add the rest of this salt into the beaker, which I'm going to go ahead and do. Ooh. All right, and I'm going to go ahead and stir that up. Now, I want you to take a look at this beaker right now. How would you describe what's happening in this beaker? I see two different states of matter. I see a solution and I see a solid that is sitting at the bottom. So I would describe this as heterogeneous. It looks like two different parts. There's two different states of matter. So anytime you have a solution in a beaker and then at the bottom you have a solid, we say that it's a heterogeneous mixture. There's more than one part. So I'm going to go ahead and agitate this. I'm going to stir it up until all of that salt dissolves. And I'm going to pause the video and come back when I'm done stirring because this is going to take me a minute or two. And we are back. So you'll notice that my vigorous stirring, that this is now a homogeneous mixture, and that all of that salt has dissolved. So I got all of that gigantic amount of salt to dissolve in this small amount of water. So now what could I do to get more salt to dissolve? How could I change this? So I agitated it and I physically pushed the particles closer together in order to get them to collide and to get the salt to dissolve. But take a look at the graph. What else could I do? Uh-oh, I'm going to move us down a little bit so that you can see that we are going to be changing the temperature. So take a look at the graph for NaNO3. If I increase the temperature, what's going to happen to the amount of salt that I can dissolve? You guessed it. The amount is going to increase because when solids dissolve in a liquid, the solid needs to act like the liquid in order to dissolve. And in order for this to happen, the particles need to get further apart. So, since the particles need to get further apart, the faster they move, the more the solid can act like a liquid. Because remember, those salt ions are taking a ride on a water molecule. So I'm going to go ahead and set up a hot plate. So we're back. So this thermometer right now is reading 25. So I'm going to keep increasing the temperature of this solution. And as I increase the temperature of the solution, what happens to the motion of the water molecules that are in that beaker? So as the particles in the beaker move faster, that we are able to see that they can dissolve more salt. So I'm going to bring this up to, let's bring it up to 40 degrees Celsius. That's very far away from boiling, but it is significant enough that we can get more salt to dissolve. So right now I have a saturated solution of sodium nitrate, and it is going to be at 40 degrees Celsius. So how many grams of sodium nitrate do I need to add to the 87 grams that I've already added today? So let's take a look at the graph. When you take a look at the graph, you're going to go to 40 degrees Celsius, follow it all the way up until you get to the NaNO3 line. Follow it across to the y-axis and estimate at 40 degrees Celsius how many grams of sodium nitrate need to be added. How many grams of sodium nitrate need to be in this solution to make it saturated? So if I already put 87 grams in, how many more grams should I add? So we know that at 40 degrees Celsius, this solution will be saturated with 105 grams of sodium nitrate. So go to 40 degrees, find that data point on your graph, 105 grams. So I've already added 87 grams, so that means that I need to add 18 more grams in order to make this solution saturated. I overshot a little bit and it went up a little higher than I had wanted because I put the hot plate on very high. So I'm going to go ahead and pause the video and bring it back down to 40 degrees Celsius. So I'll be right back. All right, so I'm back and I have cooled my beaker down to 40. So now I'm going to add in exactly 18 grams into this beaker. Ooh, a little splattery for me. All right, so there we go. So that is now our saturation mark for our new temperature. How could I get the salt that is in this beaker to come back out? So if I increase the temperature, we know that more salt can dissolve. I have to move this, it's making too much noise. We know that we can dissolve more salt if the water is hotter. But what happens when the water cools down? What is going to happen to that extra salt that was in this saturated solution. So right now I have, here we are, a saturated solution of sodium nitrate. It's just about saturated. I have a few little hanging crystals there, but they're going to dissolve. And so this is at its limit. It can't hold any more salt. There's no way that I can get more salt to dissolve into this solution unless I increase the temperature. If I increase the temperature, I can get more salt to dissolve. So what would you expect to see if I cooled this beaker down? So as the beaker cools down, what do you expect to see happening inside of this beaker? So make a prediction as to what you would see. So I'm going to do that. I'm going to let this beaker sit and cool and come back down to room temperature. So it's saturated now at 40 degrees Celsius. I wonder what the temperature is now that I stirred it up and moved it around so much. I don't know if you're going to be able to see my thermometer, but it's just under 40 right now. So I'm going to cool this down by placing it into this big beaker with ice in it. So I have this other big beaker, and this big beaker has some ice in it. So what that's going to do is cool down my solution. So I'm just going to make a bath by placing this whole thing inside, and I'm going to let it sit here. I'm going to see if I can put this camera close enough so that you can see what's happening in the small beaker. I'm going to take a temperature reading and find out what the temperature is right now. Oh, the temperature is still very high. So I'm going to let this sit. I'm going to pause the video and I'm going to come back when it has cooled down. The better view, but what you should see are that the crystals of salt are going to start to come back out of the solution. So as this cools back down, and just agitate it a little bit, you should start to see that the salt crystals are going to start to form again. And as this cools back down to room temperature, the 18 grams, or it might be a little bit fewer because it probably won't cool down as cold as I had it before. But as that happens, this is a good view. So I'm back. That took a very long time on my end, but like nothing for you guys. But what you can see is that crystals are starting to form at the bottom of this beaker. So hopefully you can see, there you go, that the solid is coming back out of the solution. So as the water is cooling down, now less salt can be dissolved, and we have, again, a heterogeneous mixture where we're getting that salt in the bottom there of my beaker. So as the water cools back down to about 20 degrees Celsius, it's really about 25 right now, which is room temperature, it's going to precipitate back out and go back to being a heterogeneous mixture. So this was 100 grams of water, and in the beginning I added 87 grams of salt. If I had 200 grams of water, twice as much water, how much salt do you think you would have to add to make the same concentration, also a saturated solution? What about if you had half as much water? How much salt would you need to add? You guessed it. For half as much water, it's half as much salt. So the idea here is that make sure that you're paying attention to the amount of water, because don't forget that the graph is calibrated for exactly 100 grams of water.